Here's an audio narration explaining grounding system selection. Several factors determine what type of grounding system to use. These include electrical code requirements. The National Electrical Code, known as the NEC, and local codes specify the minimum requirements for grounding systems. These requirements are based on the type of facility and its electrical system. Soil conditions are also important because the resistivity of the soil where the grounding electrode is installed affects its effectiveness. Available space plays a role, as the size and shape of the building site may limit the options for grounding electrodes. Budget is another factor because the cost of different grounding systems varies, so it's important to consider this along with other design considerations. Let's compare a ground rod versus a ground ring. A ground rod is a single metal rod driven into the ground, connected to the electrical system to provide a grounding path. A ground ring is a continuous loop of conductive material buried in the ground to create a low-resistance grounding path. When should you use a ground rod? Use them for small buildings or buildings with a limited footprint. Ground rods are also appropriate in areas with low soil resistivity, meaning less than 100 ohm meters. Use them also when space limitations prevent the installation of a ground ring and if cost is a primary concern. When is a ground ring required? Use them for large buildings or buildings with a large footprint. Ground rings are also required in areas with high soil resistivity, meaning over 100 ohm meters. They are used to protect against lightning strikes or high fault currents, and when multiple grounding electrodes are necessary to achieve the required grounding resistance. Let's discuss the specific case of a church. With a 600 amp 3-phase electrical service at 208/120 volts from the utility transformer, the NEC requires a grounding electrode system that meets these criteria. 1. The minimum ground rod length should be 8 feet. 2. Two or more ground rods should be used, spaced at least 6 feet apart. 3. Grounding rod should be copper-clad steel or stainless steel. 4. If the soil resistivity is high, a ground ring may be necessary to achieve the required grounding resistance. It is generally recommended to use a ground ring for a church building of the size and service. This will provide the most effective grounding path and ensure compliance with electrical code requirements.